Welcome back to another video, and we have something very quirky and special, I guess, on the bench today to have a look at from Yamaha. This is the AST-A10 Active Servo Processing Amplifier, apparently. And you might be looking at this going, okay, why are we looking at this, and what the hell is an Active Servo Processing Amplifier? Well, this amplifier runs on cartridges, and I didn't even know this was a thing, and I was completely blown away when I found out about it and started looking into it, taking me back to my childhood with Nintendo and cartridges and whatnot. And to be clear, I didn't even buy this amplifier to do a video on. It was just going to go in the shop and be used for listening to music in the background or whatever. But I hooked it up to my electrostat headphones, as I do, and I was dumbfounded with the sound of this thing, how clean it was. It was just, it doesn't look like anything special, and it sounded amazing. So I think we need to go deeper into this amplifier. We need to look at the history of it. We're going to benchmark it, we're going to tear it open, see how much power it puts down, look at its distortion and everything. But this video is going to be a little different because I think we need a history lesson about why this thing even exists. So let's dive in. So winding back the clock to the 80s, what was going on? Well, the power wars of the 70s were over. Manufacturers weren't going head to head anymore, trying to outdo each other with who could have the biggest, most powerful amplifier. There was like a massive market downturn. People weren't spending money. Companies were trying to find all sorts of niches and things that would revolutionize the audio market and bring people back, and also not have to go head to head with each other by having something that was patented or licensed and couldn't be directly copied. And that was sort of what was going on, I think, back then. And at the same time, the bean counters were stepping in. They were trying to cut costs everywhere. Amplifier build quality went downhill. There was more plastic, less metal. Component quality was starting to go downhill. And it wasn't about who could build the most stout product and be proud of it. It was about who could make the most money, could make things the cheapest, while giving the perception of having the best product still. That led to Yamaha doing a lot of different things. In the early 80s, I remember the X-Power technology that was tried for a brief period. We are going to do a video on that as well eventually. And that sort of led on to products like this that were more at the end of the 80s. And as far as I can tell, this amplifier is the very first amplifier from Yamaha to feature Active Servo Technology, which continues to this day, believe it or not. Well, at least the name does. I don't know how much is left of the actual technology, but it has changed names over the years. It used to be AST or Active Servo Technology, then it was YST, Yamaha Active Servo Technology, and now today it is known as Advanced YST, or Advanced Yamaha Active Servo Technology, which you can find on their website to this very day. So coming back to this amplifier, what was the deal with this first generation Active Servo Technology and these cartridges? Well, the idea was that you would buy a set of Yamaha Active Servo speakers, and they would come with these cartridges, and these cartridges were designed to go with that set of speakers to customize your Yamaha amplifier to suit the speaker's characteristics, its impedance curve. There was many different designs of speakers that were available, and it would turn an otherwise generic Yamaha amplifier apparently into something that is designed to run those speakers. Now, I did a bit more research, and it appears that this sort of thing went from about 1988. That was the earliest brochure I could find on this, through to about 1991, where it seems to have come full circle, and this amplifier was sort of repainted. I don't know if it was different inside, maybe it was just they just reused the chassis or whatever, and it had these really weird bong type speakers where there was only 200 sets made. They're very rare, probably some of the rarest pieces of Yamaha's history, and they can apparently be seen in some new museum in New York on permanent display, which I think is really interesting. But I will overlay here a list of what I could find. There are quite a few amplifiers that use this technology. There was a lot of different cartridges. There was a lot of different speakers. I will say that the list is not complete. I've just been Google searching, doing as much research as I can. And you might be surprised that a lot of Yamaha amplifiers from the early home theater with the AX series receivers had these cartridge slots on the back with a blanking plate, and it was just unpopulated. I don't know exactly how they worked without the cartridges. So at this point, you're probably saying, well, why do you need cartridges? Isn't a speaker or whatever, if it's 8 ohms or 4 ohms or whatever? But no, not really. A speaker will change depending on the frequency that is being applied to it and how much power is being applied to it. So from 20 hertz to 20 kilohertz, the resistance will change and the speaker will start reacting differently. And that is before you get to the crossover networks that are built into them, having tweeters and woofers and mid-range drivers. And in a lot of ways, a speaker, you know, it's also sort of an inductor and a capacitor. You've got magnetic fields to deal with. You've got motion to deal with. There's a lot going on, and it doesn't matter how linear the amplifier is, once you hook it up to a speaker, it's going to do all weird and wacky things as it goes through the frequency range of normal hearing. And finally, before we close this little background out, I'll just say that what Yamaha are attempting here is not the first time. This tube amp dates back to the 60s, and it has something called MFB, or motional feedback. And this concept was that you would have your normal speaker outputs going to your speakers, and then there'd be wires from your speakers coming back to the amplifier, and then you could adjust the MFB control with this switch here, and you could also adjust the dampening for the speakers as well. So yes, it is a new take on it with what Yamaha is doing, but it is not the first attempt to try and tackle this problem. So just before we close this out, I've got to read this gem from the AST-A10M user manual, which was an amplifier that I guess came after the one we have here. And I love this shit. This stuff's amazing. I love marketing. Not really. The AST-A90M, unlike any existing amplifier, is an amplifier that can have a negative resistance figure in its output impedance. Sure. The voice coil impedance of a conventional speaker is approximately 6 ohms. Yeah, okay, I'll give you that. And the AST-A90M can apply a negative resistance to eliminate this voice coil resistance portion. As a result, with the combination of the AST-A90M and the AST system exclusive speakers, the resistance between the amplifier and the speakers will become approximately 0 ohms. Well, yeah, because the resistance between the amplifier and the speakers should be 0 ohms, because that's technically your speaker cables. The resistance is actually in the voice coils themselves, but whatever. And the electrical current will be able to run infinitely, a condition close to superconductivity. Wow. In other words, the amplifier output voltage will direct drive the speakers, hence making it possible to provide a powerful driving force and dampen power of steady speed operation. I fucking hate sales and marketing. Let's open this thing up and have a look around. So just taking a quick look at the front before we dive into the internals. The only things to really speak of is the cartridge slot, obviously. I will mention that this is the AST-K01 cartridge, or is otherwise known as a flat amp cartridge, and this is designed for any type of speaker, basically. It is not bespoke for any Yamaha speaker model. You can use third-party speakers with it. It basically turns it into a normal amplifier again. We have level control here, which is just another word for volume control, and bass range, which is not your typical tone controls for controlling bass or boosting it. It is actually a low frequency cutoff, so you can set the minimum frequency that this amplifier will run to. If it's wide open, it's around 15 hertz, and you can dial it back so it won't go down that low if you've got a set of speakers that for some reason or another can't handle really low frequencies. And just looking at the back, there's not a lot going on, but we have two sets of inputs here, normal RCAs, but it will also take inputs from another power amplifier, which is a really unusual thing to see on an amplifier. And there's a switch here to go between the RCAs and the power amp inputs. Very similar to what you would see on a plate subwoofer yet again, which is another interesting little quirk. So taking a quick look around inside, I'm really liking what I'm seeing in here. It's really spacious design, no hot spots to speak of, nothing's been packed in there. Not something to take for granted in 80s gear, because a lot of 80s amplifiers were stupidly designed for saving money. They ran really hot, Locksman, and just basically burnt themselves out, especially with age. So the power supply got a moderately sized transformer, quite big for this application. We've got dual rectifiers running separate voltage rails, some film capacitors on each side, resistor here, probably a bleed resistor I'm assuming. Input fuse here. These capacitors are Elna for audio capacitors, and these are Nichicon LR capacitors. The outputs are from Senkin. They're 100 watts per package, which is nice. Good overhead available there. No thermal paste to speak of, just using a giant thermal pad to join this mounting bracket to the heatsink, and also thermal interface pads between the outputs and the mounting bracket. Don't see that very often, and I'm glad there's no thermal paste inside this thing. Less maintenance, they don't dry out, it's just a better overall design. I really like this silicon wrap going around the power wires also. Nice touch. There's also one here as well with just like one wire running through it, which is quite odd. Another unusual thing, this white PCB looks really good. I don't know what the material is, but it looks very nice, at least. But we have these Nichicon Muse capacitors in here, the green ones, which is very unusual to see in an amplifier like this, I would think. Especially this many of them. Like, this is a lot. The emitter resistors are here. There's 4 of them in total. They're also the test points for the bias, and I'm assuming these are bias trim pots also. There is no adjustment for DC offset, so that's not a thing in this model. The speaker protection sort of straddles between the two amplifier sections, which is a really well thought out design. So amplifier section here, amplifier section here. Speaker protection sits in the middle, and then these nice spiral wrapped wires run from the protection relay to the output terminals. I really like the design of this thing. Shielded wires on the input coming down to the tone controls and then back again. No remote pots with shafts or anything. That was one of the things that got cut out in the 80s to save money. But the shielded wire is much appreciated anyway. This is the holder for the cartridge, and it does have a connector going into the main board. You can unplug this, but it is interesting that we have a combination of connectors and also hardwired power wires also, which is not something that was super common in the 80s. Most amplifier manufacturers had moved on to connectors at this point. So to see these wire wraps still in here makes me wonder when this thing was actually designed. Good size heatsink, and also there is some capacitor glue, but this is not the sort of stuff I would be worried about. This stuff should be fine. It shouldn't become conductive or activated, and there's no other capacitor glue to speak of in this thing. There are some inductors and resistors at the back near the speaker terminals, And there's that switch, which is nothing special for going between the RCAs and the power amp input. Overall, I really like this thing. I think this is really nicely laid out and a very big surprise for something as understated as this. Also forgot to mention these other capacitors are from Elna also. They are Durex. Never really heard of these ones before, but they are apparently audio class. So that means every electrolytic in here is audio specific. And also one other attention to detail I almost missed. They've got like ferrites or magnets stuck on the side of the relay contacts, which is a really interesting attention to detail. And thought we might as well look at the schematic quickly for anyone who's interested. All the inputs are up here. We have the two RCA inputs, and these are the power amplifier inputs that will have dropping resistors, and there's some op amps here. There's a switch here that goes between them, goes straight into the level control pot to set the signal level. Then it goes across into the bass range pot with some more op amps, and then across into the cartridge. The cartridge is quite early on. I was quite surprised at that. And then it goes out from the cartridge straight into the amp modules. So amp module here, amp module here. In the middle, it seems to like power regulation. I'm assuming that's what those other two transistors are that sit in the middle of the heatsink. I haven't really dug into this, but yeah, just having a quick look at it. Transformer here, there's the two rectifiers, and then it comes out into the capacitor banks, which are positive 50, minus 50, plus 24, minus 24. Oh, and it looks like there's a minus 21.9 volt rail also. Interesting. Speaker protection here. The outputs of the amplifier modules go out through an inductor and a resistor in parallel. Speaker protection relay is there. And it appears that the secret source to this active servo technology in this generation is in this current sensing amp, which happens to be tied to the negative terminals. What is actually happening here, I'm not exactly sure, but it seems to be tapping off the positive terminal or positive line out, and then it is feeding back to the cartridge again, which is doing some interesting things. There's not a lot inside the cartridge. It's capacitors, resistors, and some op amps, but I'm sure it's feeding back to the inputs of the amplifiers at some point, and there is also global feedback by the looks of it, which goes back to the start of each amplifier module. So that was just a quick look at that. There is also a block diagram here, which I'll overlay on the screen if anyone's interested. I'm just going to give this thing a quick blowout. We're going to check the bias, and then let's bench test this thing. So this thing is looking much better after a bit of a blowout and clean. It looks almost brand new inside this thing. Really happy with its condition. Bit of corrosion on this front panel here on the black painted metal. But other than that, it looks amazing. The bias is it's starting to drift apart now, but both channels peaked at 45 millivolts basically together. And the service manual calls for 25 millivolts bias on both channels, plus or minus 5 millivolts, but that's after 1 minute warm-up, which is a really unusual way to set the bias, because normally you would firmly stabilize the amplifier and then set the bias, not do it during a cold warm-up because you don't know what the cold temperature of the amplifier is. So I'm going to leave this bias for now because this heatsink is not very warm. It's barely warm to the touch, and it's not stressed out by this bias at all. So I'm just going to leave it for the time being. As long as both channels are pretty much equal, I'm happy to move on to testing what this thing can do. So I've just been running this thing through some distortion and power measurements, and I'm just, how is this thing measuring so good? This is only 1 watt, and normally 1 watt is even harder than the higher powers because you've got distortion plus background noise to deal with. And we're already down to 0.006 This is wide open, no filters or any trickery. And I've been running this thing up and it tends to bottom out around 0.003 across most of its power. We just keep cranking this thing up. We just keep cranking it up and it just keeps going, and we're still going up. Distortion's starting to climb a little bit and it caps out around 25 volts into 8 ohms, which is, so we're up to 0.005 now, and if we go much beyond that, there it goes. There's your clipping point. So I'd say 25 volts is pretty solid. I'd say that's the absolute upper limit. Distortion is still well controlled, and that works out to about 78 watts per channel into 8 ohms. Really, really impressive. And it doesn't care. Can't even hear it. And for anyone wondering also, I decided to check the bass range controller and see if it matches up with what Yamaha specifies in this graph here. I do have the original document, believe it or not. It appears that the wide setting is about 15 hertz is its maximum, or minimum, should I say. If you go any lower than that, then it falls off. And it appears that the narrow setting is somewhere around 250 hertz. It's nice and happy there. If we go down to about 200 hertz, we can see it starting to fall off. If we go down to 150 hertz, then it's gone. And then if we start to bring that back up again, we can restore that low frequency cutoff. So yeah. At narrow, it is around 250 hertz. At wide, it is about 15 hertz. So I decided to hook this thing up to my electrostat transformers and do my usual measurements that I do with all the other amplifiers. And this thing is definitely an outlier. It is not your typical amplifier. Past 20 kilohertz, all my amplifiers driving these transformers tend to trend upwards, because they're quite difficult to drive and not like your typical speaker. So there's this natural voltage climb depending on the amplifier. They all have the same sort of trend, just at varying degrees, while this one tends to stay flat and if anything falls off a little bit. But yeah, it's just sort of shows that this is an outlier. It is not your typical amplifier. The only thing I did notice at 20 hertz, there is a bit of a bump in the frequency response, but I think that's down to this bass range adjustment and just getting that dialed in. But super clean, no noise floor, exactly what you need for driving electrostat headphones. So that is it for this video and this amplifier. There's not much else to do with it. It's working perfectly. It doesn't really need a restoration because it's built so well. Like I said, this is the stuff I love, like little sleeper amplifiers that don't look like much on the outside. No one pays attention to them, but it's what is inside that counts. It sounds great. It's got moderate power, 70, 80 watts per channel into 8 ohms. It's not a powerhouse, but it punches well above its weight. Super clean. I would say an outlier for an 80s type amplifier. They are generally not this impressive. It put down distortion figures that are better or a match for my Sansui Alpha, other than it having half the power, of course, but still, credit where credit's due. Its distortion figures are really, really low, and I think if you could pick one of these things up for a good price, then they're worthy of adding to a collection, especially for someone who collects Yamaha amplifiers. Who knows, it'd be interesting to try some speakers with matching cartridges also to see what that is all about. Hide it behind the door. It's just a cool piece of history, I think. Let me know what you think of this video. I know it was a bit different, but I thought we had to do this thing justice and go into the history of it, not just look at its performance in isolation and treat it like any other amplifier. Anyway, that closes this video out, and I will see you in the next video.